In this video, I'm going to show you how to build full registration system using Spring Boot, based on the sign-up page we made earlier. If you haven't watched the previous video, you can find the link in the description below or simply click on the pop-out banner. In fact, together, we'll initialize a Spring Boot application, establish database registration, and much more. Keep watching. Before jumping into Spring Boot, let me explain frameworks. Think of building a car. You could create the entire thing from scratch, designing and making each part like the engine, wheels, and chassis. Or you could start with a frame, which provides the underlying structure, and build on top of that. A software framework like Spring Boot works the same way. It provides foundations needed for web applications, things like the server, routing, database connections, and more. With the Spring Boot framework in place, developers don't have to rewrite all that core code. They can focus on building the specific parts they need for their application, like the unique logic, APIs, and user interfaces. Spring Boot handles the common repeatable tasks so developers don't have to reinvent the wheel each time. Just like the car frame provides the foundation so you can add an engine, seats, and accessories, let's start with step number 1, which is setting up foundation using Spring Initializer. Spring Initializer is a website or web-based tool used to set up Spring Boot projects in an easier and efficient manner. Let's head to Spring Boot Initializer. I will provide the link in the description. Choose Maven as the build tool. Select a compatible Java version. Now let's add dependencies. Click on Dependencies to add the building blocks our application needs. Let's add Lombok. Simplifies boilerplate code, reduces repetitive code. Spring Web enables web application development. Spring Security provides user authentication and authorization, potentially including video login with additional configuration. PostgreSQL. If you plan to use PostgreSQL as your database. Spring Data. JPA simplifies database interactions using JPA, Java Persistence API. Java Mail Sender enables sending email notifications. It's optional. Once you've added the necessary dependencies, click Generate. This creates a zip file containing the pre-configured Spring Boot project. Download the zip file and unzip it somewhere convenient. Now let's open that project folder in VS Code, and it's time to explore what Spring Initializer has cooked up for us. Let's navigate around a bit. First, open the folder called SRC. This is where the core code of our application lives. Inside SRC, you'll find another folder called Main. This is where the main parts of our application reside. And within Main, there's a folder named Resources. This one holds important configuration files for our project. Now inside Resources, you might see a file called application.properties. This file stores configuration settings for our application. While .properties is common, Spring Boot also supports using YAML, which is known for its readability. If you prefer YAML, we can actually rename this file to application.iml. We'll explore configuration details later in the video, but for now, just know that renaming is an option. Okay, let's move on to the next step, which is database setup using PostgreSQL. Let's jump back to our code and do some changes to our application file to accept our Postgres server. First things first, we gotta tell the server how to handle errors. Be a good communicator when things go south. Here's what we can write. Server error include message. See these lines? We're basically saying, hey server, whenever there's an error, be transparent. Show the whole error message and any data binding errors, like if someone types in weird stuff where a number is expected, in the response. That way, we can figure out what's wrong much faster. Next up, let's configure the connection to our PostgreSQL database. This is like giving Spring Boot a map and a secret handshake to access our treasure chest of data. Here's the code. This section provides the essential details for Spring Boot to connect to your PostgreSQL database. Let's break it down. URL, this is like the special address that tells Spring Boot exactly where to find our database. It typically looks like JDBC PostgreSQL localhost 55432 database name, where localhost might be different if your database is on another machine, and 5432 is the default port for PostgreSQL. I am giving as registration as database name, username. This is like a secret handshake or code word that grants access to the database. Password. This is the super secret key to your treasure chest. Important. Never write this password directly in the code. We'll handle that securely later. Now the last part is optional, but it deals with how we talk to the database using JPA and Hibernate. These are like fancy tools that help us translate our code into database speak. Here's the code. This section has a setting called DDL auto set to create drop. This is a powerful tool, but be careful. It tells Hibernate to automatically create all the tables it needs in the database when the application starts, and then drop them when the application stops. This is great for development because it saves time, but never use this in a production environment. You don't want to accidentally wipe out your data. Let me add a couple more info in the YAML file. There you have it. Next, let's download Postgres server from its official site. Once you've installed Postgres, simply start the application through its interface. You'll typically find a Start button or similar option. This will launch the Postgres server and database. Open up your terminal. We'll use the PSQL command to interact with the PostgreSQL server. Make sure you're connected to your PostgreSQL instance before proceeding. Now let's see what databases are currently available. Type \L and press enter. This will list all the existing databases on your PostgreSQL server. Time to create our database. Type create database registration. That's created B followed by the name you want for your database, which is registration in our case, and a semicolon at the end. Press enter, and PostgreSQL will create the new database for you. Double-check your work. Run the L command again. You should now see the newly created registration database listed among the existing ones. Awesome! This means that in the application's configuration file with the connection details pointing to the registration database, your application will be able to connect and interact with it. Alright, it's time to see our Spring Boot application come to life. Head over to your project directory in your code editor. Find our main class. In our case, it's called demoapplication.java. Locate this file and right-click, or use the equivalent command on your operating system to run the application. This will fire up Spring Boot and all its components. Once the application starts, open up your web browser. In the address bar, type http://localhost 8080. Now here's where things get interesting. Remember how we configured Spring Security while initializing? You might see a default Spring Security login page coming up. That's because Spring Security kicks in and requires authentication, which means we can only see any pages for that matter in the application after authentication. So we need to configure Spring Security to use our custom login page instead of the default one. Next step, setting up our Spring Security. We need to configure our Spring Security to use our custom login and access our registration page. Currently, Spring Security enforces authentication for all URLs. This means if the request is not authorized, the application will show default login page provided by Spring Boot. We need to tell Spring Security to use our custom login page and allow access to the registration page without authorization. Let's jump back into the code. Let's create a package called security and a class named securityconfig.java inside it. Spring Boot mainly use annotations, so let's give securityconfig.java some annotations. Configuration. This tells Spring Boot that this class holds important security configurations for our application. Enable web security. This activates Spring Security for our application. Now inside securityconfig.java, we need a method to define our security rules. Let's call this method security filter chain. This method will return a security filter chain object. The security filter chain method will take an HTTP security object as a parameter. This object represents the core of Spring Security configuration. We'll use it to define things like login forms, authorization rules, and more. Inside the security filter chain method, we'll configure everything and then return the HTTP object using .build. This builds the final security filter chain object. We'll configure Spring Security to use our custom login page. Inside the HTTP object, we'll use the .formLogin method. This method allows us to define how users will log into our application. We'll chain a Lambda expression onto .formLogin to configure specific details. Inside the Lambda expression, we'll use the .login page, login method to specify the URL for our custom login page. Remember that login page you created earlier? This is where we tell Spring Security to use that page for login functionality, then permit all at the end. But there's more. We also need to allow access to the registration page without requiring authentication. All right, let's make sure users can access the registration page without needing to log in first. Spring Security enforces authentication by default, so we need to create an exception for the registration URL. Inside the security filter chain method of your securityconfig.java class, we'll use the .authorize HTTP requests method. This method allows us to define authorization rules, specifying which users can access which parts of our application. Inside the .authorize.p requests method, we'll use a Lambda expression to define our authorization rules. Here's where we'll create an exception for the registration page. We'll use the request matchers method within the Lambda expression. This method allows us to specify patterns for URLs we want to match. We'll pass reccar signup, or whatever URL you're using for your registration page, as an argument to our request matchers. Finally, let's grant access to anyone who tries to access the registration page. We'll chain the .permitAll method to the .request matchers call. With this configuration, users won't need to be logged in to access the registration page. They can freely sign up for your application. Now let's tell Spring Boot where to find our login and registration HTML pages. We'll use controller classes to handle user requests and interact with these pages. Before creating controllers, let's organize our project. Move your login and registration HTML files to the template folder within your project's resources directory. This is the convention Spring Boot uses for HTML templates. We also need our CSS and JavaScript files. Inside the static folder within your project's resources directory, create two subfolders, CSS and JS. Move your CSS and JavaScript files into their respective folders. This helps keep your project organized and allows Spring Boot to locate these resources easily. Finally, let's create a controller class. In your project, create a new package called controller. Inside this package, create a class named contentcontroller.java. Spring Boot relies on annotations to understand different parts of your application. So, let's annotate the content controller class with a controller. This tells Spring Boot that this class is a controller and will handle incoming requests from users. Inside the content controller class, we'll create a method to handle the login page. We'll use the getMapping annotation on top of a method to define a mapping between a URL and a method in our controller. Inside the annotations parentheses, we'll specify the URL for our login page, which is typically our login. The method itself will be a simple string return type method. In the return statement, we'll specify the name of the HTML file responsible for displaying the login form. This will usually be the name of the HTML file you created for the login page. Next, we'll create another method to handle the registration page, same as above. Now, run your Spring Boot application. You should see the login page displayed in your browser. However, you might notice that the CSS isn't loading correctly. This is because Spring Security still restricts access to static resources like CSS and JavaScript by default. Let's fix that by adjusting our security configuration in securityconfig.java. We already added an exception for the registration URL. Now, we need to do the same for our static resources. Remember how we added .request matchers and permit all to allow access to the registration page? Same way, let's append the path to CSS and JavaScript folder. Now rerun your application. You should see the login page displayed with the applied styles from your CSS file. This confirms that both the HTML content and the CSS are loading correctly. Let's load the registration file as well. All right, let's get our application connected to a database. This will allow us to store user information like usernames, emails, and passwords. Let's create a new package called model in your project. Inside the model package, create a new class named myabuser.java. We'll annotate this class with entity to tell Spring Boot that it represents a database entity. This annotation is essential for Spring Boot to recognize myabuser as a model class and interact with the corresponding database table. Now let's define the table structure by specifying the properties of the myabuser class. These properties will map to columns in the database table. Long. This will be the primary key for the table, uniquely identifying each user record. We'll use the ID annotation to mark it as the primary key. Additionally, we'll use the generated value strategy generation type auto annotation to tell the database to generate unique IDs automatically. Username string. This will store the user's username for login purposes. Email string. This will store the user's email address. Password string. This will store the user's password. However, we'll never store plain text passwords in the database. We'll discuss secure password hashing in a later step. For each property, we'll also create getter and setter methods. This allows us to access and modify the property values within our application logic. With the model class defined, let's run the Spring Boot application again. Spring Boot is intelligent. When it detects a new entity class annotated with the entity, it will automatically interact with your configured database, usually based on your application.properties file, to create the corresponding table structure. If everything is set up correctly, you should see a message in the application logs indicating that the MyAppUser table has been created in your database. This is a great sign that your model class and database connection are working as expected. Next, let me define our objective first. When a user attempts to log in, the username is submitted. Our goal is to verify if this username exists in the database. If it there, then, we need to say to the Spring Boot use this username and password to authenticate. Now that we have our user model, MyAppUser, we need a way to interact with the corresponding user data in the database. Here's where the repository comes in. Think of the repository as a specialized access point for our user information. We'll create an interface named MyAppUser repository and annotate it with our repository. This tells Spring Boot it manages this interface and provides functionalities to interact with the database. We'll extend the interface with JPay repository MyAppUser long. This pre-built functionality simplifies our code by providing common database operations like finding and saving entities. We specify MyAppUser as the entity type and long as the primary key type, since our ID is a long. Finally, inside the interface, we'll define a method named findByUsername that returns a MyAppUser object. This method allows us to retrieve a specific user from the database based on their username. This functionality is crucial during login when we need to verify if a username exists and if the entered password matches the one stored for that user. We've established the user model and the repository for interacting with user data. Now, let's introduce the user service, a crucial component that bridges the gap between our application and Spring Security's authentication process. We'll create a class named MyAppUser Service and annotate it with our service. This annotation tells Spring Boot to manage this class as a service and make it available for dependency injection. We'll implement the User Details Service interface provided by Spring Security. This interface defines a contract for retrieving user details for authentication. One key method within this interface is loadUserByUsername, string username. LoadUserByUsername returns user detail. We will define that inside the function. One more thing we need to do that is auto-wiring our repository. We call the findByUsername method on the repository, passing the received username. This method searches the database for a user object whose username matches the provided one. The findByUsername method returns an optional MyAppUser. This optional signals that the search result might be empty, user not found. If the user exists in the database, we will set username and password from database to the user detail object for it to return to secure.it config file to authenticate. If the username doesn't exist, the optional will be empty. We throw a username not found exception to notify Spring Security of an invalid username attempt. We've established the user model, repository, and service for interacting with user data. Now, let's configure Spring Security to leverage our custom logic for user authentication. By default, Spring Security enables protection against cross-site request forgery, CSRF, attacks. In some scenarios, you might need to disable it, not recommended for production. Let's disable it. As we were discussing, we need to use our service here. For that, by using our auto-wired, we tell Spring Boot to inject an instance of MyAppUser service, allowing us to access its functionalities. Next, we need to return our myAppUser service as user detail service. For that, let's create a bean and return user detail service. Next, we need to tell the Spring Boot about authentication we will use, and it's called Authentication Provider. For the we will provide in another beam over here. Then we will create a method called Authentication Provide and return Authentication Provider. Inside this method, we will give DAO Authentication Provider. This is what we use for authentication. Next, we are going to set user detail service from our myAppUser service and return our provider. Let's run the program. Keep in mind we don't have any details in database. Let's load the login page. Let me give some values and submit. As you can see in the logs, it's running the find by username function, means the login function is working. Let's work on our registration page. First things first, we need to create a class called registrationcontroller.java. This is where we'll write the code to handle. Next, annotate the class as REST controller inside the class. Let's define our post mapping. This method handles post requests for signup. The request URL is specified as rec signup. The consumes attribute indicates the request body should be in JSON format, application JSON. Let's create method createUser takes a myAppUser object as a parameter annotated with our request body. This signifies that the request body will contain JSON data representing a new user. This data will likely include the user's username, email, and plain text password. One more thing we need to do before going forward, that is, we'll auto-wire the myAppUser repository to interact with the database. The createUser method can optionally return myAppUser repository.save and pass user. That's it. Then we need to define a couple of things in the signup page. The objective is while posting the request, it should be in JSON. For that, we will define a script. Inside the script, we will get the submit button element by using getElementById. Then we will set a click event over here and set our username, password, email to a data JSON, then send it in the request. We will get the username, email, password, and confirm password using getElementById and its value. If the password and confirm password is same, then set the data in JSON format. Then fetch our registration request and set the header as JSON and send the data. Now let's run the application. Let's load our signup page and give the input values username as test, email as testetest.com, password as test. Now click on Submit button. Let's check this data in our database. For that, let's go to our Postgres terminal. Then type, select from myAppUser. This will return our table. As you can see the entry we done now. But there is an issue with this entry password. It is not encrypted. For fixing that, let's go to our security configuration file. Create a bean. Then create a method called password encoder with a return object as password encoder object, which is provided by Spring Security. Then return method as bcrypt password encoder provided by Spring. Next, let's go to our registration controller and encode the password while registering. For that, we need to auto-wire our password encoder and set password in encoder value. Let's run the application now and see it reflects or not. Enter our details in the signup page and click on Submit. Then go to our terminal and see if it is there or not. Here, as you can see, the password is in encoded format. One more thing we need to do that while log in, also we need to encode the input password. Otherwise, it will check encoded password with plain text password. Let's go to our security config and inside our authentication provider set password encoded also. While authenticating, Spring Boot will automatically encode the input password string. Now let's test it out. For that, rerun the application. Then register our user details. Next, try to log in using the values. As you can see, it got authenticated and made all URL accessible. Let's try other URLs also. As you can see here, it is not redirecting to login page. Before login, this was the case. Let's create a landing page. For that, go to ChatGPT Ask to create a home page using HTML and CSS. In our project, let's create a file called index.html. Let's use the code generated by ChatGPT. Now, let's connect this landing page to Spring Boot application. Open up your Content Controller class. We'll use a get mapping to map the root path or to the landing page. This method essentially tells Spring Boot, when a user visits the root path, IU, return the logical view name index. Spring Boot will then look for a template named index.html within your configured template location, usually the templates folder, and render it as the response. Finally, let's ensure users land on the landing page after successful login. Go to our Security Config class. Locate the configuration for form-based login, form login. Set the default success URL to achak index. This tells Spring Security to redirect users to the landing page, index, after successful authentication. Let's run our application and check. Let me enter our username and password. I goes to our index page. Awesome. Let me make a couple of changes in the login page. Setting the link to registration page. Currently, accessing unauthorized URLs after login might result in an error. Let's improve this by creating a custom 404 error page. Inside your project's templates folder, create a subfolder named public if it doesn't exist. Inside the public folder, create another subfolder named error. Inside the error folder, create a new HTML file named for.not4html. Write some basic HTML content for this page. It could include a heading like 404 page not found, a message explaining that the requested resource could not be located. Once you've created the custom error page, restart your application. Now, after successful login, try accessing an unauthorized URL. This could be a non-existent path or a resource you haven't secured yet. If everything is set up correctly, you should see your custom for.not4 error page instead of the default error message. Alright everyone, let's fire up our Spring Boot application. Once it's running, we'll navigate to the application URL in our browser. Since we haven't logged in yet, the application doesn't recognize us. Let's try accessing a random URL. As expected, Spring Security redirects us to the login page. Now let's test the login functionality. We'll enter an invalid username and password combination. Upon clicking Login, Spring Security should handle this and display an error message. Perfect. It tells us our credentials are bad. Now let's create a new account. We'll navigate to the sign-up page and fill in the registration form with a valid username, email, and password. Once done, we'll click Submit. Assuming the registration was successful, we can now try logging in with the username and password we just created. After clicking Login, Spring Security should authenticate us and boom! We're successfully logged in and redirected to the home page, landing page. This signifies a successful login flow. We've just built a basic login system using Spring Boot. While this is a great start, there's always room for improvement. In future videos, we'll explore handling more complex scenarios, implementing email authentication, enhancing security measures. If you have any questions, leave them in the comments below. Don't forget to like this video and subscribe for more awesome Spring Security tutorials.